Hello guys, so welcome back to my channel where I'll be posting about DSS solutions every day, and today is day 5th of doing so, and today we'll be looking forward to lead code number 560, which is subarray sum equals k, and the topic of this problem is prefix sum. So yes, let's get to the problem and let's see what the problem states. So the problem given to us is like we will be given nums of array, and we will be given some elements within that, and we will be given some elements in that array. The elements can be from -1000 to +1000. So within this array there are positive and negative numbers both, and its length can be within this range. Now the problem states us that this is nums and will be given with a k. K is our target. We are asked that how many subarrays within this array can be there whose sum is equal to this target. Let me like write an example for you guys. Let's say if we have an array, I will take both plus and minus. Let's say we have this array, or to make it better I'll say yes, we will have negative and positive elements both, right? So the problem here asks us, like, if we are given with k, let's say k is 3. Okay, we are given with this array and we are asked to find subarrays within, how many subarrays are within this array whose sum will be equal to the target. As we can see, there are some subarrays we can definitely look at the first glance, and it is like one subarray, and yeah, I guess this is pretty much right now that I can look forward to. The first approach of this problem will be the brute force solution of this problem, and it is like the approach one will look for every other subarray within the array. We will explore all subarrays and look their summation if it is equal to k or not. This approach will have a time complexity of O of n squared, because we would have to run a nested for loop in which a block will run for O of n square times, like n square times it will run. Yes, and the time complexity of this block will also be O of n square, right? So yeah, this is the first approach to this problem. So the second approach of this problem is an optimal approach which requires us to understand prefix sum. What is prefix sum? Prefix sum is basically the summation of first n elements within the array, and here is the other subarray. So this is prefix sum, right? And now within the problem we are given that there can be negative and positive elements both. So we cannot have the second approach as maybe a sliding window, because we don't know if, like, let's say we have the window size of like one or two elements at first, like one element, and if it is smaller than k, we are increasing window size on the basis of that. We if we are doing this, we don't really know like maybe if we are here, we have minus 1 1, which like the summation of this is coming as 2. And since k is 3, we will have to increase the size of window. We're increasing the size of window, and we are then getting minus 2 here, which will moreover decrease the size of this array to 0. So we don't really know if by increasing the window size we will increase the sum or not, right? So we don't have this confirmation, and that is why we will use something as hash map within this problem. We will use something as hash map. We will be storing prefix sum and count, like how many times this prefix sum is coming, right? So within the hash map, let's say 1 minus 1 1 2 minus 2 2. Let's say this is an array, and k is given to us as 3. Now initially we will take our prefix sum as 0, and it will have a count of 1, which will state that if our prefix sum is here, it will have 0 summation, right? So we will take it right here, and then when our first iteration will move on, we will go here. We'll move to our second iteration. For like first iteration, it will have summation of 1 and it will have count of 1. Then we will move towards 0. Like the second iteration, it will have plus 1 and minus 1. So we will have count of 0 to 1, like 2, right? And then when we will move forward, we will go towards 1, we will have 2 count of this, okay? And then when we will take 2 into the summation, we will have 3 as with count 1. Then we will subtract 2, which will come out to as the count of 1 will be 3, okay? And then we'll add 2 to this, which will increase the count of 3 to 2. Now the summation of all these counts will be our answer. 2 plus 3 plus 2, which is 4 plus 3 7, right? Okay, we are taking this because obviously there are negative elements and we need to take it into consideration. So what is happening? The thing which is happening is that we are taking prefix sum of this particular array. Let's say we're taking prefix sum, and we're essentially asking that while taking this prefix sum, we are asking that is there any subarray within this array which will be equal to k minus, like target minus, which will be essentially equal to, let me see, total we will ask like prefix sum minus target exist within this array or not. If we have 3, we will say we're having a prefix sum of 1 right now minus 3, which will boil down to minus, which will be like minus 2. Do we have minus 2 summation anywhere within this hash map? If it is there, then we will like add it to our answer, okay? Similarly, we will have here, like let's take this example. Let me just write it down somewhere else. So I'll take 1 minus, I'll use different pen for this. 1 minus 1 1 2 minus 2 and 2. So if we are taking 1 minus 1, if we're taking this part of the subarray within this array, and we know its prefix sum to be 3, and then 3 minus 3 is and k is also 3. So 3 minus 3 is 0. Now what we are asking is, do we have a subarray whose sum is equals to 0? Do we have? Yes, we have. And if we try to eliminate this subarray, what we will be left out with is k, and we will add it to our answer. So since we have 0 like 2 times, we will have k equals to 2. Like first subarray will be an empty array, right? So we will have this plus this part of the subarray. To our answer, we will find the summation of this and we will get the answer. Okay, so the time complexity of this solution will be big O of n, because we will just have to go through the array one time and we will have the solution, and the space complexity will be used by the hash map, and obviously searching within this hash map will be taking a constant time complexity, so that it will not take a lot of time. The space complexity of this will be just dependent upon hash map, which would be under big O of n. Okay, so let's try to implement this problem and see. So first of all, I'll take okay, I can take it as n, and we'll take an unordered map. Key and pair, key will be your integer and count will also be your integer. We'll take it as prefix count. Okay, and we will initialize to prefix count of 0 will be equal to 1. Like at first index we will okay, wait a minute. What are we doing every time? We will take prefix sum, we will take summation, we will take current sum, and we will add it again and again and again. And okay, the pre sum we can take it as current sum. We'll add it to every element. Okay, after adding that element, we will essentially ask if previous sum minus target is somewhere present in the hash map. If prefix count of And after checking this, what will, if like there are elements present within the hash map, we will add it to the result, and otherwise we will take the current sum and we will increment its count. Okay. mm, okay, what I'm using here is nums, which is not a valid thing. We should be using it. Okay, so our solution, let's submit it and find out if this is uh, passing all the test cases. Okay, yes, so we so this is the solution to this problem, and what we are essentially doing here is like first we are taking prefix sum. By the way, there is no use of this size. Yeah, there was literally no use of this size. It's just a habit. Okay, so first we are having a base case of 0 comma 1, as we've already told you here, and after that current sum we are initializing it to 0 and result also to 0. Then within this for loop, what we are doing is this process what we were discussing about. We are taking our prefix sum, we are looking forward to this equation. We are checking if previous sum minus k exists within the hash map or not. Okay, if it doesn't exist, or if it exists, our result will update towards whatever the count value will be present in that situation, uh, in that key. Then we will increment the count for that particular sum. Like for 1 we incremented, first it was from 1, then 2, then 3. Yeah, so that's it. Thank you guys for watching my video, and we will meet again with another problem. And okay.